Hello everyone, my name is Rachel. Before we start, I'm going to just say that I'm incredibly nervous today because I received a lot of exciting news. I was just told that I was on the cover of Hackspace magazine this morning, and I managed to get a publication published on Nature Communications. So I am like, okay, thank you. Okay, I hope I'm not standing right in the middle of the slide so you can't see. So today I'm going to talk about making in the age of the internet. What it means is basically how creating and making has gotten a lot easier if you want to learn something and through the access of internet and information. Hello, I am Rachel. I'm known as Konichiwakitty online. It is my fashion technology brand, wearable fashion technology brand. I'm a maker, hacker, fashion tech engineer, designer, as well as a full-time stem cell scientist and mental health advocate. You can also find me on social media as Konichiwakitty, where I post all my latest projects. So why am I speaking today? Today I'd like to talk to you about several things such as making with wearables, how I got about making fashion technology, to scare you a little bit about tissue engineering, what it is, where we currently stand with it, and how advanced it actually is. And lastly, just to share my experiences in access to information as well about crediting where credit is due. And if there's some time, I will talk a little bit about balancing between work and play and mental health. So first of all, making wearable fashion technology, how to get started. So what is wearable technology? When we think wearable technology, we often think things like Fitbit, fitness trackers, VR headsets. Wearable technology is a blanket term for electronics that can be worn on the body, either as an accessory or part of material used in clothing. So in the early days, clothing was used as a carrier where we would attach chunks of electronics. Not to say that I don't do it now, but things have advanced where material that's used, such as conductive thread, conductive cloth, is also used to enhance a user's experience with wearable technology. So wearable technology can be categorized into two types, namely health tech and fashion tech. Health tech is often related to things like fitness trackers that helps you keep track of the number of steps you take, the number of stairs you've climbed, number of calories you've burned. But I do feel that in terms of health tech, it is secluded to a smaller group of people. The reason being, what do calories mean? You have to understand the information that is provided to you in order for you to actually harness the proper use of it. On the other hand, fashion tech is relatable to everyone. You wake up in the morning, you have to make a conscious fashion decision whether you want to pick this shirt or that shirt, do those trousers go with this shirt, and so on. So it is relatable to everyone. Fashion tech is also not about placing a computer or a phone onto your body, but rather to enhance a user's experience. How so? Such as putting sensors into clothing so that when you are experiencing a theatrical act, you actually really feel vibrations and it's a really enhanced experience. In other terms, it can also be a way for you to express yourself even more. So just to show you a little bit of my personal fashion tech projects that I've created, this is an example that I have made using, I didn't expect that to be music. Can I silence it? No. Well, this is a project that I have made. It is meant to be a floral necklace, and you can see that it moves clockwise and anti-clockwise and changes color. The purpose of it is really for it to be expressive and fun. The next project that I have made, this is actually my first fashion tech project. It is basically a Hello Kitty holding on to a pepperoni hat that sits atop a Raspberry Pi. The purpose of it is really to express myself. This is my creative outlet. It's also to inspire other people, especially young girls, to try STEM education or electronics and programming. So the question that I get really often is how to get started. How did you come about doing this, combining electronics, crafting, and art? So I started creating fashion technology in April 2017, which is not very long ago. It's about a year. So I started by not actually having any formal education or knowledge about electronics or programming. This made it really difficult for me to actually learn because I realized that when I wanted to look for something, I didn't know what to look for. I didn't know the terms. I just wished that I was working at a desk with someone right beside me that I can go, hey, what's this? What do you call this thing? So, how to get started? So first of all, incredibly important, for you to get started, you need inspiration. Inspiration is what would drive you to dig further, to want to know more. So there are already existing fashion tech companies such as Cute Circuit, who has designed dresses for performers such as Katy Perry, or a Twitter dress for Nicole Scherzinger, which displays tweets on her dress. Following that, there is also this lady called Anouk Riprek, who created a dress using servos and 3D printing that projects spider-like legs when people come into her personal space. Very useful. Following that, there is Elius Design, who uses technology to create the pieces, such as CNC milling, laser etching, and 3D printing onto prosthetic covers. With that in mind, I was very excited. I was like, oh, how do I begin? And then I realized that these companies, they don't reveal how they made it. They don't give information such as if they made the hardware or whether they bought it on AliExpress. So, how did I get started with making? First of all, attend events. Events are very important because a lot of the times they are displaying their products, and you can ask the person standing right beside the product, what is this? How do you use this? How do you apply this to this and this? Can I do this or that with this? So, ask questions. Thirdly, use the internet. The internet has been an amazing source of information to me, but you must know how to use it. So, in the traditional days, people use forums. It is still very helpful because there are certain applications or errors that still occur even though the answer to the forum was probably like 10 years ago. So that has been really helpful. Or chat rooms, such as Discord or Slack. On top of that, I found what to be really helpful is social media. Why? Because most of the time, I don't know what I'm looking for. I don't know what to search, what to type into Google. If I have an issue that needs debugging, and I don't know what I've done wrong, the best thing I can do with Google is copy the whole thing and paste it into it, and hope that it will give me something in return. With social media, such as Twitter, I discovered that you can actually take a photo of your problem and upload it, and hashtag makers help. It reaches a very wide number of people simply because people start retweeting. People start sharing, and there are so many different platforms such as Guild of Makers and communities that will start helping you. And this is almost immediate because somehow everyone is online all the time. So, what else is helpful? Customer services. If you purchase something from them, or you didn't, just ask customer services. Why? Because they're meant to provide you incredible customer services. I know this might be a little bit mean, but this was actually how it got started and linked with Twitter. So I would retweet things, and the experts who are with certain companies, such as Raspberry Pi, Pimorni, they would reply, and they are customer services. So from there, I realized that if I upload something, customer services reacts really quickly. So to get started, these are your best options if you don't know what you're looking for. Following that, another way to start learning or to get started is using introduction kits. These kits are meant to give you the first step towards doing something that you thought you'd never do, or if you don't know exactly where to start. So this is a kit that I created recently because I got a ton of questions asking how do you combine crafting with electronics. And I found a really useful skill to be soldering. With these kits, you should be able to find links on web pages such as Pimoroni or Raspberry Pi, and these links will give you video tutorials. If you are a visual learner, this is really important. And a lot of the time, the information on how to use the products are available freely. Whether you are creating with the kit that's provided or creating something that is relatable to that kit, relatable to a part of the kit, for example, a video that shows soldering, you could still apply it to something else that you're doing. But these are all readily available. So, the second part of my talk is creating human organs. I am a full-time PhD student who uses stem cells to grow eyeballs in the lab for blindness. So, how to get started on creating organs? So, to create organs, the term used is tissue engineering. Tissue engineering is the use of a combination of cells, engineering, and materials and methods, and to replace biological tissues. Basically, to break it down, you need living cells from the patient. You need a scaffold which provides a home for the cells to grow on. You need growth factors if you want to direct the cells towards a type of organ. And then you need vasculature to provide food to the cells. So, what are stem cells? Stem cells are basically baby cells. They are the building blocks of your body. During embryonic development, an embryo is a mass of stem cells. So from an embryo, the stem cells start to develop into different parts of the body, the arms, the legs, the brain, and all the other organs. This development has several different growth factors that will contribute to the brain, the lungs, the heart, the liver. If you can harness these growth factors, you have control of building a human body. So the next thing that you'll need is a scaffold. How to build a scaffold? These are examples of projects that I've worked on. That is a liver and this is a large intestine. So to build a scaffold, you need to obtain an organ. It doesn't have to be a live organ. It can be from an animal. And the reason being, once you've stripped it of all its cells and DNA, this scaffold will retain its natural extracellular matrix, but will not cause any problems in terms of organ rejection, because once you seed it with the patient's own cells, it becomes a personalized organ. So these overcomes problems such as the need for organ donors or organ rejections. So, tissue engineering. An example of tissue engineering is like building a house. Stem cells are your building blocks. And as stem cells mature, they play specific roles, such as it can become a window, a door, the rooms become living rooms, bedrooms, and the scaffolding provides the structure for the cells to grow on. What else does it need? It needs growth factors and vasculatures. In order to complete our project, we also need literature, whether it is published or unpublished. And lastly, the goal is to go to a shop one day, pick an organ off the shelf and say, hey, I want to add a little bit of this, a little bit of that, just to enhance it. Like maybe you want a liver, you might be doing a little bit more drinking, so you just want to add a little bit of this, a little bit of that. So, with published and unpublished literature, trying to link it back to things like open access, I've learned that if you wish to publish an article with a journal, you have the choice of paying, if you are a wealthy research group, of paying to cover the costs that subscribers would normally pay. This way, the literature is freely available to the public. Otherwise, the article would normally be restricted to subscribers only. As a perfect student, we also have alternatives, such as Sci-Hub, where if our institution is not subscribed to a journal, we have something in the background. And this Sci-Hub has worked really well. Sci-Hub believes in providing open information for everyone. Obviously, there were legal issues, and this was shut down, but then so many, even more started popping up. So Sci-Hub is something that we all really believe in, but journals are journals. As I said earlier, unpublished literature is equally important. Why? Because when we are trying to publish as a research group, it is basically a race against time. If you publish before me, I have to know what you've published and immediately take that as a stepping stone towards my next publication. Unpublished literature is important, and that means presentations at conferences. If someone presents the unpublished data at a conference, how can you collaborate and work together with that person to achieve a goal that you probably were aiming for? So, scientific research and information. So the next thing I'd like to talk about is the obstacles and lessons learned when it comes to using information and crediting where it's due. So how many of you have heard this phrase? Getting more and more common these days. It is so annoying. This is especially said now that information is so easily available online. When people share their ideas or their new projects on Twitter, on social media, we get to see a lot more of it. But does that actually mean that our ideas are no longer original? I believe that each person's idea is original, but no one wants to say that we all have the same problems. An idea is basically a solution that you came up with because you encountered the same problem. Isn't that right? But who wants to say, hey, you copied my problem? The truth is that we are a lot more relatable than we realize. And this era of information made us notice that, hey, actually, we're doing a lot of the same things. We're a lot more alike than we like, really. And yeah, so I strongly am still fighting for original ideas. If it happens that someone else made the same thing that you do, that doesn't mean that your idea is less than them. This is really important because a lot of times people made something and they feel disheartened because they're like, oh, someone else made it too. Does that discredit my own project? No, you made it, own it. So, credit where credit is due. If you go, you're having a problem and you can't think of a solution, you go on Google, do a little search, and you find that someone gives a solution that helps you. Credit them. How to credit them? Ask how would they like to be credited, because some people, they're a little shy. They don't want, their information to be shared. They don't want to get attention. So ask. Also, if it's okay to use whatever it is that they've done. Following that, inform them how it will be used, how you're planning to share it on social media, or give them an example of how much attention it might be getting. And most importantly, say thank you. Let them know that you appreciate that they shared an idea that they've created or something that they've made. This is especially important because nowadays people feel like ideas are so easily taken. But when you say thank you, it encourages them to do even more. And lastly, I think I already said this point. What did I say? Why? Why it's important to credit when credit is due? Because it encourages the maker or whoever who took the effort to post something, because it takes time to actually write out all the things a description. So encourage them. And this is especially important for small businesses, especially for those who are trying really hard to grow a business. And if you use something and create something similar, let them know that they inspired you. How much time have I got? Okay, because I do have a little bit of time, I think. I'm going to talk about why I do what I do. So, as you guys know, I'm a PhD student, full-time, doing stem cell research. And on the other hand, I'm also doing fashion technology, which is completely irrelevant. So the reason why I started doing this, well, actually there's a relevance, I'll tell you later. The reason why I started doing this is because after I finished my master's, I was terribly burnt out. I did tissue engineering for my master's and I absolutely loved it. But I was still burnt out. I think a lot of times when you are so in love with something, you don't realize that it actually takes over your whole life. Does your pie chart of life look like this? I think like a lot of us, we feel really, really lucky, to find a passion in something that you do, but it can be very consuming. For example, I would tell myself, I'm going to go take a break, going to go to the park, but I'll bring a research paper with me because, it's just a relaxing read. But that is work. That is work. You're not actually taking time out to do something else, to give your brain something else to do. So I was burnt out. I had really bad insomnia. I had severe anxiety and depression, even though I was doing something I really loved, which made it even harder to understand why I was experiencing all these struggles.
You needed a boyfriend.
You're probably right. I needed a social life. You're right, because you are absolutely right. I needed a social life, because this is...
students like this. I'm an academic and I used to advise students.
Yeah.
I said, get yourself a girlfriend or a boyfriend, and it worked.
It makes life a lot more interesting.
Couldn't get one myself, though.
It makes life so much more interesting. You're absolutely right. So, no. But with making, my pie chart of life is so much more colorful now. With making, I met my boyfriend. With making, it's incorporated so many other things, such as me doing a talk right now, meeting so many new people. With work, I was just talking to myself every day. So I have decided to incorporate this part of creative outlet and recreation as part of my life, even though it takes a lot of prioritization, making time, it is worth it. It includes so many things that I wasn't aware about before. The needs that your body actually wants, and so on. So, variety is the spice of life. Thank you.
Thank you very much, Rachel. We have a little bit of time for questions, probably while Bracken sets himself up. Questions for Rachel? Yes, at the back.
And the audience can help amend my comment. There was a radio before an announcement that David Solomon was stepping down as one of the directors or trustees of Merrill Lynch, or which leads the company up, and that standing in his place was someone who'd been working for that company for decades. And this is the banking and insurance sector kind of thing. But it was found out the person who was taking over apparently was a DJ in an electronic music group.
I have heard that.
No one knew that. So this is so nice.
I think it's the new chief executive of Goldman Sachs.
Goldman Sachs,
That's
yeah.
it. Yes, that's it.
Yeah.
So,
David Solomon.
so I just wanted to say that to reinforce what you were saying at the very end.
Thank you.
Yes. having been a PhD student, I recognise that graph quite a long time ago. So, and I think you touch on something that's rather important for us, which is the question of mental health, which has been a hidden away issue inside the software engineering industry for many, many years, and it's just starting to come out and people are talking about it. It's very good to hear people addressing like it too.
So one question. So how close do you think are we to actually automatize the process of this tissue generation? So in that sense, that combines this making thing, right, of 3D printing and stuff, together with designing new organs and new materials.